Okay, so here's the solution number 4. This one's actually pretty straightforward because all of these are in parallel. And if you were looking at the circuit and you weren't sure, a method that you can use to draw nodes is to follow along the line. And see, can you all see that in real time? I'm following along. So as you follow along, and then don't cross the line until you see an element. So we see the element here, and then I keep going. Follow the line, saw the element, and don't cross until you get to the element. That is a way to circle nodes. And once you kind of get good at it, then you'll be able to do it pretty fast. So I'll do it in green. Now, like often when I'm doing nodes, I'll just, do a big circle like that. That's the only 2 nodes in this problem. It's a little thick. I should probably thin that marker out a little bit. But that's the only 2 nodes in this problem. And if they share the same 2 nodes on the outside, then that means that they're all in parallel, which means that it's 1 over 180 plus 1 over 90 plus 1 over 60 plus 1 over 60. All of that in parentheses. And there's kind of 2 ways to do this. I usually write it like that just because it's easier. So I put -1, that's what it's to. But the other way that you could write it, and it's probably fastest if you have the TI-36, is if I erase those, I'll erase the nodes just so we can see more clearly, is if you put it in a fraction. And so the fraction button on your TI-36, if you hit the fraction and you just put a 1 on top, or you do the 1 over, if you just hit the 1 over, it often puts whatever your previous answer was below it. But if you wanted it in one step, you hit the fraction button, type 1, go down. Then you put all of these as fractions, and it's much faster than it is doing all of the inverses and doing it one at a time. You can do it all in one step, and I can see this thing right here entirely on my calculator. And that way it's kind of a sanity check for you that you typed it in right versus typing it along the way, pressing enter, plugging in the next answer. Just put all of that into the calculator using the fraction button. If you want to talk with me later, let me know about how to use the TI-36. But that's the fastest way that you can do that. And that all came out to 20 ohms. So example number 10. Right here. Now this one, I meant to give you a current divider problem, so I'll send you the solution for number 11. But for number 10, this goes back to the idea of parallel elements. So if I'm just circling the nodes, here's a node, here's a node. Notice that inside that node, there's no elements at all. If there was, it would cease to be one node. I'd have to split it up. But this is all one node, and so this is kind of like how I said if I hold 3 pins between my hand. Well, these are all 3 in parallel, these 3 elements. So that means that 36 volts, that is from here to here, well, that's the same as across here, R1, and it's the same across R2. So if I know the voltage across R1, I need to solve for I1, and I have R1. So if I'm solving for I1, it's simply VR1 divided by R1. Well, that voltage is the same because they're all in parallel. So 36 divided by 2, that comes out to 18 milliamps because that was 2 kilo ohm. I2, it's the same voltage across. 36 divided by 8. Make sure I'm giving you the right numbers here. I'm not typing them into the calculator in real time. Yep, 4.5. 4.5 milliamps. For this one, for number 11, because I'll dismiss class here in just a sec, and if you wanted to work this one before you get to your homework, I'll send out the solution. But this one is just practicing using current divider rule. So here is all of the nodes. They're all in parallel. So I could solve for the I total, right? I don't have I total, but I could solve for I total because I could solve R total is all 3 of these together in parallel. Then I could use Ohm's law, right? For the total, V total equals I total, R total. And then once I have I total, then I can use the current divider rule. And in this case, the I equivalent is the I total because that's what's going into node A. And then for each of the ones that I needed to solve, I1, I2, and I3, this Rx is whichever one. So for I1, there's Rx. For I2, there's the Rx. For I3, there's the Rx. So you can solve number 11 on your own, and I'll send out that solution as well.